So we're going to continue with our lesson on 11.5, and we're going to start off with 28 and 34, where we're going to solve the equation given. And so in order to solve the equation given, we need to, figure out what we're looking at. So in 28, we are looking at n squared equals 64. So when we normally solve an equation, we want to get the variable on one side, everything else on the other. That's already done for us in 28, so we're good. The next thing is we need to get n by itself. And currently we have n squared. So what we're going to do is we're going to take the square root of both sides to get rid of that square. So square root of n squared equals square root of 64. And we know from yesterday the square root of a variable squared is the absolute value of that variable is equal to, and then the square root of 64 is 8. Okay? And so absolute value of n equals 8 must then mean that we have n equals negative 8 and positive 8. That's our answer. Okay? Let's look at another one. In 34, we've got 50b squared minus 450 equals 0. So first thing I'm going to do is add 450 to each side. To get the b squared by itself, I'm going to divide both sides by 50, and so I get 9. And so then from here, I'm going to take the square root of each side, just like I did in the last problem. So we get absolute value of b is equal to 3. So b is equal to plus or minus 3. If you're noticing a pattern yet, you should realize that we should always get a plus or minus root, right? Because we talked about this at the beginning of the roots, where roots have a principal and then they have a negative version. So then let's look at 40. For 39 to 53, you're going to use your calculators, okay? So for 40, we've got a squared is equal to 154. So again, I need to make sure that I have my variable on one side, everything else on the other, which I do. Then I'm going to take the square root of a squared just so I can get a, because that's what I'm looking for. So a is equal to, absolute value of a is equal to 12.4. A is equal to plus or minus 12.4. Like so. And if you're wondering where I got 154's root from, I just plugged it into my calculator, okay? For 50, we've got 0 equals 6n squared minus 0.42. So just like with 34, first thing I'm going to do is add 0.42 to each side. And then I'm going to divide both sides by 6, so I get 0.07 is equal to n squared. I'm then going to take the square root of each side, so I get 0.3 is equal to absolute value of n, so n is equal to plus or minus 0.3. Now let's look at 54. 54 says a plus 3 quantity squared plus a minus 3 quantity squared is equal to 256. So first thing I'm going to have to do is I'm going to have to FOIL this out. All right, so I FOIL out a plus 3 squared, so I get a squared plus 6a plus 9. Then I need to FOIL out a minus 3 quantity squared, so I get a squared minus 6a plus 9 equals 256. I'm going to combine like terms on the left, so the 6a's cancel. I'm left with 2a squared plus 18 is equal to 256. I'm solving for a here, so I'm going to subtract both sides by 18. So I get 238. And then I'm going to divide both sides by 2. So I get 119. And then I'm going to take the square root of each side, so I can get a. So a, absolute value of a is equal to 119. So a must be, sorry, not 119, is equal to 10.9. So a must be plus or minus 10.9. Okay? The second lesson is the Pythagorean theorem. This is on page 532, and it's section 11.6. The Pythagorean theorem says that in any right triangle, so the key thing here is that you have a right triangle. If you do not have a right triangle, you cannot use Pythagorean theorem. Okay? It says that in any right triangle, a squared plus b squared is equal to c squared. Okay, and I've drawn a right triangle on the right here. Notice that c is always the hypotenuse, so it's always the longest side. Okay? And right triangle means we have 90-degree angle, right? So let's look at 2. In 2, they give us that A is 5, B is 12. What is C? So we know we're going to be using the Pythagorean theorem here. So I'm going to write that down. And I'm going to plug in for A and B and solve for C. So I've got 5 squared plus 12 squared is equal to C squared. This is 25 plus 144 is equal to C squared. 169 is equal to C squared. Just like on the last slide, we're going to take the square root of both sides to solve for C. So C, absolute value of C, is equal to 169. So C is equal to 13. C is equal to plus or minus 13. Okay, but since we're working with triangles, C is a length, and lengths can never be negative. So that negative is out, so C is just 13. For 12, they're going to give us 3 lengths, and they want to know that if those 3 numbers could represent a right triangle. Okay, so they gave us in 12 3, 9, and 11. So I'm going to draw a right triangle here, and let's say it actually works. So that means that C would be 11, right? Because C is a hypotenuse. Hypotenuse has to be the longest. And then we got 3 and 9, and those can be either side. So I'm going to see, to figure if it does represent a right triangle, you're going to see if the Pythagorean theorem is true. So you're going to see if A squared plus B squared is equal to C squared. So if A is 3, B is 9, and C is 11, we've got 3 squared plus 9 squared is equal to 11 squared. This is 9 plus 81 is equal to 121. 9 plus 81 is 90, which does not equal 121. So the answer is no. Let's look at another one of those. In 18, it says, do the lengths 3A, 4A, and 5A represent a right triangle? So again, I'm going to draw a right triangle with these as my lengths and see if it passes the Pythagorean theorem. So we've got 3A, 4A, 5A. Remember that C always has to be the longest of the 3 lengths. Okay, so I'm going to do A squared plus B squared equals C squared. I'll plug in, so A is 3A, so it's 3A squared plus 4A quantity squared equals 5A squared. 9A squared plus 16A squared is equal to 25A squared. 25A squared is equal to 25A squared. This is true, so the answer is yes. For 22, we're going back to what we were doing in the first 9 problems of this page, so we're going to solve for a missing piece. Okay, so in 22, it says that A is equal to 15, B is equal to 1/5 A, and C is equal to what? So if you notice, the slight difference is that they gave us a number for A, but they gave us an expression for B. So first thing we have to do is find B. So we're going to we know B is equal to 1/5 A, and we know that A is 15, so we're going to replace that with a 15. So we know that B is equal to 3. And now we're going to solve Pythagorean's theorem for C. So we've got A squared plus B squared equals C squared. 15 squared plus 3 squared is equal to C squared. 225 plus 9 is equal to C squared. This is 234 is equal to C squared. Absolute value, once we take the square root of both sides now for C, absolute value of C is equal to 15.30. C must then be plus or minus 15.30. Since we're dealing with lengths though, C can only be positive, so C is 15.30. Lastly, we need to find a and b to the nearest hundredth for when a is equal to 3b and c is equal to 20. So instead of where in 22 we were able to find a value for b right away, we're going to sub 3b for a in Pythagoreans. Okay, so we know that Pythagoreans is a squared plus b squared equals c squared. B, we know nothing about, so we're going to leave it as the variable it is. We know a is equal to 3b, so this is 3b squared plus b squared is equal to c squared. C is 20, so I'm going to put a 20 here and square it. And now I'm going to solve for b. So we've got 9b squared plus b squared is equal to 400. So 10b squared is equal to 400. Divide both sides by 10. We get 40. And then we're going to take the square root of each side to solve for b. So b is equal to, absolute value of b, is equal to 6.32. b must then be plus or minus 6.32. So b, since we're dealing with triangles, is only 6.32 because it cannot be negative. Now that we have b, we need to find a. And we know that a is equal to 3 times b. So we're going to plug in what we got for b, which is 6.32. So a must then be 18.96. And that's the answers. And that's the lesson. So the homework due Friday is page 526, numbers 27 to 53 odd. You are allowed to use calculators for that section. And page 532, numbers 1 through 29 odd. I'm going to say you should use a calculator on the entire thing just in case it's going to make it easier for you to take those square roots in the Pythagorean theorem there, okay? And just as a quick reminder, test 19 is next Tuesday.